wiring harnesses, wiring diagrams, connector numbers, ground locations? Does it seem like the struggle with vehicle electronics never ends? Well, just because a system is electronically advanced doesn't mean it has to be difficult to diagnose or repair. In fact, with a large reduction in the number of circuits, by grouping together the fuses and the relays in 2 locations, and with the ability to use the scan tool and MDS for diagnosis, it shouldn't be difficult at all. And that brings us to the subject of this month's MasterTech: Concorde, Intrepid, and Vision Body Electrical. Some of you may remember a brief look at vehicle electronics in the Concorde, Intrepid, and Vision Technical Overview release in June 1992. Our purpose, however, is to take an in-depth look at the body electrical system of the vehicle. This month, we'll look at component locations and body control module functions and features. We'll examine wiring harness routing, we'll look at the power distribution points and grounds of the vehicle. We'll cover the electronic pinion system and vehicle multiplexing, and we'll examine some of the convenience features found in Concorde, Intrepid, and Vision. To begin, let's take a look at the location of the vehicle's components and examine some of the functions and features of the body control module. The Concorde, Intrepid, and Vision vehicles are equipped with up to 6 control modules. 3 of these control modules are located in the engine compartment, and 3 are located in the passenger compartment. In the engine compartment, located under the air cleaner assembly, is the powertrain control module, or PCM. On the opposite side of the engine compartment, to the outside of the battery, is the transmission control module, or TCM. And on vehicles equipped with anti-lock brake or traction control systems, the ABS and traction control module is attached to the hydraulic assembly. In the passenger compartment, the remote keyless entry module is located under the instrument panel top cover, just right of center. The passenger airbag system diagnostic module is located under the center of the instrument panel assembly on the top of the center tunnel. Above the right side kick panel in the passenger compartment is the body control module, or BCM. In addition to these 6 control modules, there are a couple of other electronic component locations which you should be aware of. The first is the electromechanical instrument cluster, which is located on the left side of the instrument panel. Next is the overhead travel information system, or OTIS display head, which is located on the center top of the windshield between the sun visors. And third is the automatic temperature control head, which is located in the center of the instrument panel beneath the radio. Also located in the passenger compartment is one other very important feature of the vehicle's electrical system, the data link connector. Located under the instrument panel above the accelerator pedal, all Concorde, Intrepid, and Vision electronic systems use this one connector for scan tool or MDS diagnosis. Now, before we get into wiring harness routing, the body control module deserves some special attention. It's important that you're familiar with its function and operation because of its role in the body electrical system of the vehicle. The body control module functions as the management center for most of the body electrical functions of the vehicle. The BCM provides the vehicle with a long list of features such as chimes, courtesy lamps, cluster operation, headlamp time delay, instrument panel dimming, and windshield wiper and washer. On Concorde, Intrepid, and Vision, there are 2 body control modules available, a base module and a premium module. The premium module provides the additional automatic temperature control and the overhead travel information system features. On both base and premium modules, after the ignition switch is turned to the lock position, the body control module goes into something called a sleep mode. During sleep mode, parts of the BCM are powered down or turned off, resulting in a lower ignition off-current draw. The body control module enters this sleep mode 30 seconds after the ignition is turned to lock, unless one of several conditions, such as headlamp time delay is active, exist. For a complete list of conditions that will keep the BCM from entering sleep mode, refer to this month's reference book. Vehicles equipped with the remote keyless entry have an additional condition to meet before the body control module will enter the sleep mode. Provided all other sleep conditions are met, the BCM will enter sleep mode 30 seconds after the illuminated entry fade to off feature. If for any reason the BCM sees a signal from the dome lamp or one of the door ajar switches, it will remain in the awake or operating mode. However, the BCM will activate the courtesy lamps for only 1 hour before fading the lamps to off. When the BCM is in the sleep mode, it will turn on to an operating mode or power up when any of several conditions are met. For a complete list of these conditions, refer to this month's reference book. During the first power-up on a new vehicle, the body control module uses the C2D bus to learn what components are present on the vehicle, and all of its functions are set to factory preset values. Later in this program, we're going to discuss how the BCM communicates with other modules over the C2D bus. But now, let's try a review question. If the dome lamp on a Concorde, Intrepid, or Vision is left on, after 15 minutes, will the BCM be in a sleep mode or an operating mode? The operating mode. Remember, if the BCM sees a signal from the dome lamp or one of the door ajar switches, it will stay in the operating mode, activating the courtesy lamps for 1 hour before it fades them off. In this section, we're going to take a quick look at Concorde, Intrepid, and Vision's wiring harness routing with the help of some service manual diagrams and our vehicle. Wiring diagrams are located in Section 8W of your service manual. Beginning in the engine compartment, you'll notice that the headlamp and dash wiring harness runs pretty much in a horseshoe pattern around the compartment. Now, let's follow the harness, starting at the right rear of the engine compartment. We can see that at this point, the engine and transaxle wiring branches off from the headlamp and dash harness. From here, the headlamp and dash harness continues past the powertrain control module. Right headlamp and parking lamps, horn, and radiator fan. It goes on around the front of the engine compartment to the left side, where the battery wiring harness joins it. After the battery harness branches off, the headlamp and dash harness runs past branches for the left headlamp and parking lamps, transmission control module, power distribution center, and anti-lock brake system hydraulic unit, and attaches to the instrument panel harness via a 40-way connector. The instrument panel harness runs from the junction block to the passenger side of the instrument panel. One branch of the harness routes through a hole near the right speaker to serve items located on top of the IP. The left side body harness begins near the junction block, where it connects with the instrument panel harness, junction block, headlamp, and dash harness, and the left front door harness. From here, it runs to the rear of the vehicle, branching off into the left rear door wiring, the rear compartment and deck lid wiring, and anti-lock brake system wiring. The left side body harness also crosses over the body, where it connects with the power seats and continues to the right rear door wiring. On the right side of the body, the harness runs from the instrument panel to the rear of the vehicle, branching off into the right front door wiring and rear shelf and rear compartment wiring. Next, we're going to discuss the two power distribution points on the vehicle. But first, let's try a review question. Where in the Concorde, Intrepid, and Vision service manual would you find a diagram of the instrument panel wiring harness? Section 8W, Be sure to look at this section for diagrams of all the wiring harness routing. There are two major power distribution points on Concorde, Intrepid, and Vision vehicles. The first, located on the driver's side of the engine compartment near the front, is the Power Distribution Center, or PDC. The majority of the vehicle's electrical current supply passes through the PDC, which contains both relays and fuses. Also, if the vehicle is equipped with the ABS option, notice the two ABS relays attached to the outside. A graphic on the inside of the Power Distribution Center cover identifies each item. You can also refer to your service manual or this month's reference book for an identification of the relays and the fuses in the Power Distribution Center. The other power distribution point is the junction block, which is new for Chrysler vehicles. The junction block, located at the end of the instrument panel on the driver's side, reduces the number of circuits, splices, and connectors in the vehicle's wiring by moving all previously standalone passenger compartment relays into a common housing. The junction block contains fuses, relays, and circuit breakers. The mini fuses in the junction block receive voltage from cartridge fuses in the Power Distribution Center. Now, before we move on to examine the vehicle's ground locations, let's try another review question. Where do the mini fuses in the junction block receive their power from? The mini fuses in the junction block receive their power from the cartridge fuses in the Power Distribution Center. On Concorde, Intrepid, and Vision, 7 major ground locations provide paths for current to flow back to the battery. The first ground is located on the left front unibody frame extension. This ground serves several items, including the ABS system, left front end lighting, radiator fans, and wiper system. The second ground is located on the right front unibody frame extension. This serves items such as the right front end lighting and transmission control module. Ground number 3 is located on the starter and provides a high current ground for the starter. This also serves as the main battery ground for both 3.3 and 3.5 liter engines. The fourth location is on the left rear cylinder head of the engine. It supplies a ground for the left and right oxygen sensors. A fifth ground is located on the lower left kick panel and serves the seatbelt switches, door lock switches, fuel tank, power seats, power windows, and power mirrors. Ground 6 is located on the lower instrument panel to the right of the steering column and serves a whole list of items. Included among these items are the ignition switch, the body control module, the mechanical instrument cluster, the overhead travel information system, the remote keyless entry module, the automatic temperature control module, and the passenger airbag system diagnostic module. Finally, the 7th ground location is on the left side of the trunk. Here, ground is provided for the high mount stop lamp, all right and left rear lamps, the premium sound amplifier, license plate lamp, power antenna, and deck lid release solenoid. In addition to these 7 major ground locations, there are 3 ground straps located in the following areas: at the back of the radio, attached to the center support bracket, from the right cylinder head to the right engine cradle and frame rail, and at the power antenna. For a complete list of ground locations and the items they serve, refer to this month's reference book. In our next segment, we're going to talk about the electronic pinion system used on Concorde, Intrepid, and Vision. But first, let's look at a review question. True or false? On both 3.3 and 3.5 liter engines, the main battery ground is located on the left front unibody frame extension. False. On both engines, the main battery ground is located on the starter. One advanced Concorde, Intrepid, and Vision feature is the electronic pinion system. In this system, the transmission control module supplies the vehicle speed signal for increased reliability. Instead of using a vehicle speed sensor and mechanical speedometer pinion found in previous transaxles, the TCM uses the pinion factor and the transaxle output speed sensor to calculate the vehicle speed. The pinion factor, consisting of the differential gear ratio and tire size, is programmed into the TCM, eliminating the need for a pinion. The transaxle output speed sensor relies on input from the 24-tooth transaxle output shaft. The sensor sends a 24 pulse per revolution AC signal to the transmission control module. The TCM then applies the pinion factor to the signal to determine the vehicle speed and sends this information to the PCM via a hardwired circuit. The PCM then communicates vehicle speed information over the C2D bus to the other modules. Next, we're going to discuss Concorde, Intrepid, and Vision's vehicle multiplexing system. Like other Chrysler vehicles, the Concorde, Intrepid, and Vision use vehicle multiplexing to reduce the number of vehicle circuits. Vehicle multiplexing, first introduced on Chrysler, Plymouth, and Dodge in 1988 and on Jeep and Eagle in 1991, refers to a system that can send several messages over the same channel or circuit. Two types of multiplexing are featured on Concorde, Intrepid, and Vision: resistive multiplex switches and the Chrysler collision detection system, usually referred to as the C2D bus. Now, most of us have already heard of the C2D bus, but what are resistive multiplex switches? These are switches that allow multiple signals to be sent on a single wire to a control module. Sounds simple, right? Well, it's a little more complex than it sounds. Let's take a look at one of these resistive multiplex switches, the windshield wiper switch. First, let's look at how it works. The wiper switch sends signals to the body control module on a single circuit. These signals vary in voltage, allowing the body control module to interpret different requests. These voltages are varied by the use of resistors built into the switch. Now, let's take a look at how to diagnose a problem with the intermittent wipers. A customer comes in complaining that her windshield wiper time delay isn't working properly. Following step 1 of your 6-step troubleshooting procedure, you verify the customer's complaint. You find that the wipers operate on high and low, but in the intermittent mode, only one of the 6 time delays seems to be working properly. In your service manual, there are several tests for troubleshooting 2-speed problems in wipers with intermittent delay. In this case, however, we are concerned specifically with the intermittent wiper function, so we go to the intermittent wiper switch resistance test. Your first step is to remove the wiper switch by disconnecting the connectors. This will allow you to access the switch pins. Next, turn the switch to the position you want to check. Let's put the switch in the low speed position first, just to be sure everything is working properly. Now, using an ohm meter, test for continuity between the terminals I and M of the switch. Your service manual helps you locate the correct terminals. In this case, our ohm meter reads approximately 1 kiloohm. The chart in our service manual tells us this is the correct resistance for the switch in the low position. Now turn the wiper switch back to position 1 of the 6 delay positions. And again, test for continuity between terminals I and M. This time we get infinite resistance, indicating there's an open somewhere in the variable resistor of the wiper switch. To repair the problem, you'll need to replace the wiper switch. There are 2 other resistive multiplex switches found on Concorde, Intrepid, and Vision. They are the door lock switch and the speed control switches. See your service manual for diagnostic tests on these switches. The other type of vehicle multiplexing used on the Concorde, Intrepid, and Vision is the Chrysler collision detection system, or C2D bus. The C2D bus used on the Concorde, Intrepid, and Vision contains the greatest possible number of controllers on the bus. Do you remember why the system came about? Briefly, the Chrysler collision detection system was introduced because it offers the benefits of wire reduction, elimination of internal controller hardware, current reduction across sensors, and enhanced diagnostics. Components of the system include bus plus and bus minus circuits, the data link connector, and the modules which communicate on the bus. The controllers on the bus share information by sending and receiving it over the C2D bus. As we have already discussed, C2D bus operation in detail in past MasterTech and Videotech programs, we're going to move on to discuss the bus particular to the Concorde, Intrepid, and Vision. If you would like to review C2D bus information presented in previous programs, refer to February and March 1991 MasterTech, or for those of you who received the Videotech program, some C2D bus information can be found in the November 1991 and October 1992 releases. The Concorde, Intrepid, and Vision C2D network includes a total of 8 controllers. They are the powertrain control module, transmission control module, electromechanical instrument cluster, passenger airbag system diagnostic module, ABS control module, ATC control head, overhead travel information system, and the body control module. Diagnostic tools such as the scan tool or MDS can also interface with the network. You may have noticed that the remote keyless entry module is not on this list. That is because this module does not communicate over the C2D bus. The remote keyless entry module is hardwired to the body control module. It sends the body control module information about the illuminated entry feature. Also, the ABS control module has a limited role on the bus. It communicates only with the diagnostic tools. The body control module is an essential part of proper vehicle operation. Through its use of the C2D bus, the BCM provides the vehicle with a number of features, including courtesy lamps, chimes, and windshield wipers. The BCM will perform vehicle functions by receiving input information, analyzing it, and operating actuators or displays. Feedback signals tell the BCM how certain components are responding to its output signals. Now, before we move on to discuss some of the convenience features the BCM provides, let's take a look at an example of how the BCM interacts with other modules on the bus to provide the driver with essential vehicle operating information. In this example, we're going to look at vehicle speed. We've already seen how the transmission control module determines vehicle speed using the transaxle output shaft RPM and the pinion factor. We also know from our discussion of the electronic pinion that the transmission control module sends the vehicle speed signal to the powertrain control module via a hardwired signal. Once the powertrain control module receives the vehicle speed signal, it converts it to a signal which is sent to the body control module over the C2D bus. The vehicle speed, like all powertrain control module information for the electromechanical instrument cluster, must first be processed by the body control module. Once the BCM processes the information, it calculates the position of the speedometer gauge and transmits this position across the bus to the electromechanical instrument cluster. The instrument cluster then displays the correct speedometer and odometer readings. The body control module also uses the vehicle speed signal to calculate information which is sent over the bus to the overhead travel information system. Not all of the information the BCM uses is communicated via the C2D bus, however. As we can see from this diagram of part of the premium body control module, the BCM also communicates with a number of sensors, switches, and relays which are not on the bus. These sensors, switches, and relays, such as the washer fluid switch and the ambient temperature sensor, also provide the BCM with information about the operating conditions of the vehicle. In many situations, the BCM uses information it received over the C2D bus to determine outputs to the sensors, switches, and relays. For example, since windshield wiper time delay will vary with vehicle speed, the BCM uses the vehicle speed signal we just discussed to determine when to activate the wiper relays. Just a reminder, diagnostics for any of the systems on the bus can be performed using the scan tool or MDS. Now, let's try another review question. The BCM communicates with every controller on the C2D bus except one. Which controller does the BCM not communicate with? The ABS control module. Remember, this has a limited function on the bus. It communicates only with diagnostic tools. As we have seen, Concorde, Intrepid, and Vision can be equipped with a long list of interesting electronic features. Some of these features have been discussed in this and in past programs, but a few deserve some more attention. Let's begin by looking at the Message Center. The Concorde, Intrepid, and Vision Message Center is simply an instrument panel component containing 6 lamps. 2 lamps inform the driver that a door or trunk lid is ajar. The door ajar lamp is grounded by the body control module if any door is ajar, and the trunk lid ajar lamp is grounded through the trunk ajar switch. Another lamp informs the driver of a low washer fluid level. Like the door ajar lamp, this lamp is also grounded by the BCM, this time when a low fluid level is sensed. The amber anti-lock warning lamp informs the driver of a condition that prevents the anti-lock brakes from functioning. Ground is supplied to this lamp either by the ABS control module or through the ABS main relay. There are also 2 traction control system lamps, one indicating that the traction control system is active, the other that there is a system malfunction disabling traction control. Both of these lamps are grounded through the ABS control module. Concorde, Intrepid, and Vision may also come equipped with the optional Overhead Travel Information System, otherwise known as OTIS. If this option is included, the system provides the driver with a compass reading, ambient temperature, average fuel economy, distance to empty, instantaneous fuel economy, a trip odometer, and elapsed ignition on time. The OTIS communicates over the C2D bus with the body control module to receive all of this information except the compass reading, which is internal to the OTIS module. Your service manual contains detailed information on the various functions and settings for the Overhead Travel Information System. It also contains information on display diagnostics, compass calibration, and demagnetizing procedures, and variance setting procedures. There is also a self-diagnostic test for the OTIS. To begin the self-diagnostic test, press the CT and step buttons at the same time with the ignition off. Then, while continuing to hold the CT and step buttons, turn the ignition on. The OTIS will light all segments on the display for 2 to 4 seconds. Release the CT and step buttons and check for any segments that are not illuminated. If OTIS displays pass, the module is okay. If a fail message is displayed, or if any of the display segments are not illuminated, the module should be replaced. If the message CCD is displayed, check for an open or a short in the C2D bus communication wires. Press the CT or step buttons to exit the self-diagnostic mode. Another interesting feature on the Concorde, Intrepid, and Vision is the headlamp time delay feature, which provides the safety of headlamp illumination when leaving a vehicle in an unlighted area. If the ignition switch is turned off while the headlamps are still on, and the headlamps are turned off within 45 seconds, the BCM will provide a 90-second time delay before turning off the headlamps. The BCM provides this time delay by controlling the headlamp time delay relay on the far right of the junction block. By turning the headlamp switch to either the parking or headlamp position, or turning the ignition switch to the run position during the 90-second time delay period, the delay feature will be stopped. The feature is also disabled if the headlamps are not turned off within 45 seconds of the ignition switch. Earlier in this program, we looked at the windshield wiper switch as an example of resistive multiplexing. However, we should also mention that in the intermittent mode, the wipers are speed sensitive. This means that the time delay between wipes changes with vehicle speed. Normal time delay varies between about a half a second to 18 seconds, but if the vehicle is traveling at a speed of less than 10 miles per hour, the time delay is doubled. As a result, the maximum allowable time delay for this feature is 36 seconds. Now, let's try one more review question. You'll need your service manual for this one. According to the demagnetizing procedure found in Section 8C of the service manual, what is the purpose of the 8.5 by 11 sheet of paper placed on the roof of the vehicle directly over the compass? The purpose of this paper is to protect the roof panel from scratches and to define the area to be demagnetized. Finally, before we wrap up for the month, we need to talk about 2 technical service bulletins dealing with Concorde, Intrepid, and Vision body electrical items, which you should be aware of. Be sure to let your service writers know about these bulletins, so when writing up repair orders, they can indicate when problems might be related. The first is a reminder that the body control module updates the fuel gauge only when the engine is running. Without the engine running, there may be an incorrect fuel level reading, which may cause improper diagnosis. So remember that whenever diagnosis or repair of a vehicle requires fuel gauge monitoring, the engine must be running. This information can be found in TSB number 08-17-92. The second, TSB number 08-19-92, is a notice that on some vehicles, customers are complaining that the accessories, like the radio, wipers, and turn signal lamps, will still operate when the ignition switch is in the off or lock position. If you run across this problem, you should check to see if the ignition switch circuit is still powered when the ignition switch is in the off or lock position. If it is, replace the ignition switch as described in your service manual. Note that it is necessary to remove the foam from around the old switch before removing the screws and to install the foam onto the new switch after replacing the screws. This month, we've talked about the body electrical layout and some of the interesting systems and features on the Concorde, Intrepid, and Vision. If you would like to learn more about body electrical systems, you may enroll in one of the training classes offered by Chrysler Service Training. Consult your technical training course selection guide for details. Well, that's it for this edition of MasterTech. Be sure to join us next month when we'll talk about alternative fuel vehicles. So long for now. From a service perspective, nothing's more aggravating than intermittent problems that fail to appear once a vehicle is in the service bay. Not being able to duplicate a customer's complaint is frustrating. It almost makes you wish you could ride along in the vehicle with your DRB2 in hand as the customer drives to work and runs errands, waiting for the elusive problem to occur. Of course, that's a luxury no one can afford. But there is something now available that provides you this kind of round-the-clock diagnostic patrol, the MDS CoPilot. The CoPilot is a compact, portable data recorder that attaches to an engine's electronic management system. It consists of a recorder and a remote control activator that attaches inside the vehicle's interior. The CoPilot works on most 1987.5 to current model year vehicles equipped with onboard diagnostics. Let's review how it works. The first step involves setting the CoPilot recorder and preparing it for vehicle use. With the MDS unit on, select Data Recorder Functions from the main menu. Once the CoPilot program loads, the MDS Vehicle Diagnostics information screen appears. Enter the vehicle information as you would for the data recorder, including your technician identification, the VIN, repair order number, and the vehicle mileage. Then select the prompt, Quick Setup to Record Vehicle shown above, and press Next menu. Attach the 8-receptacle CoPilot power cable to the power port located on the front of the MDS. This will turn the CoPilot recorder on, as indicated by the red and green LEDs on the face of the recorder. Next, connect the MDS data transfer cable to the recorder unit by first attaching the 4-pin serial port cable to the MDS serial port. As the CoPilot software is being downloaded from the MDS, these LEDs will illuminate to indicate progress or alert you to problems. When both LEDs are on, a system memory test is being run. When the red LED is off and the green LED is flashing, the MDS is being recognized and the program is loading successfully. If the green LED is neither lit nor flashing, there's a problem. Refer to the instruction manual for help. Next, attach the CoPilot to the vehicle. First, disconnect the MDS data transfer cable from the CoPilot recorder and place it with the SCI data transfer cable. Then plug the SCI receptacle into the vehicle diagnostic connector. This is located either under hood or, in the case of LH, under the dash in the passenger compartment. For the under-dash connectors, secure the recorder in a safe, out-of-the-way location, such as inside the driver's side door pocket or under the seat. Make sure the CoPilot and cables are free of dirt and that all cables are clear of the accelerator and brake pedals. For under-hood connections, secure the CoPilot recorder to a stable area near the connector, but out of the way of moving engine parts as shown here. Use the adjustable straps that are provided with the CoPilot kit. With the recorder attached, plug the remote control activator unit into the recorder. Attach the remote controller to the visor so the driver can easily press the record button while driving. Make sure the cables don't interfere with visibility. Turn the ignition on and press the button on the remote control unit to test the CoPilot for correct operation. The 2 recorder LEDs and the 1 remote controller LED should illuminate in the following combinations to indicate stages of CoPilot operation. While the CoPilot is attempting to communicate with the vehicle, the recorder unit red LED will flash while the green LED is on steady. When an event has been triggered, the recorder's green LED flashes along with the remote controller's LED. And finally, when the CoPilot is recording, the recorder's green LED and the remote controller LED should both be flashing. By pressing a button on the activator, a customer can record engine operating parameters at the exact moment a problem occurs. The CoPilot captures the data and stores it for later use. 45 seconds worth of data can be stored at a time, and as many as 3 separate recording periods can be stored. When the customer brings the vehicle back into the dealership, you can upload this information to the MDS, the same way you do with the data recorder, and use the recorded information to begin your diagnosis. Attach the CoPilot to the MDS using the same procedure as when you download the software to the CoPilot. Connect the MDS data transfer cable, attach the 4-pin serial port cable to the MDS serial port, attach the 8 receptacle power cable to the MDS power port, which will turn the CoPilot on. Select the data recorder function menu from the MDS, then at the next menu select, get vehicle events. This will upload the captured data. When you load the event to the MDS, you'll need to label each recording the same as you do when uploading test drive information from the DRB2. Select Display All Vehicle Events from the MDS Data Recorder main menu. Once the events are uploaded and labeled, they can be graphically displayed on the MDS. The graphic display shows the status of different engine operating parameters before, during, and after the customer triggered the CoPilot to record. The trigger point is represented by a dashed line. Data to the left of the dashed line took place before the trigger. Data to the right took place immediately after the trigger. The CoPilot's internal programming may be updated periodically by using the MDS's flash programming option. The only other aspect of CoPilot's use you need to be aware of is reviewing its operation with customers. When you turn the vehicle over to the customer, take a few minutes to explain the reason for the CoPilot as well as how it works. Explain that they should drive in a normal manner until the intermittent condition appears, at which time they simply press the button on the remote control activator. Let the customer know that the LED on the remote control activator unit will illuminate when the key is turned on and the CoPilot is talking to the PCM. The same light will flash while an event is being recorded and for 10 seconds after a trigger. For customers of newer model vehicles, explain that the CoPilot's LEDs will stay on for 30 to 40 seconds after the ignition key is turned off. Also, opening the door on many newer vehicles will also cause the CoPilot to activate and stay lit for the same time period after the door is closed. Both of these conditions are because many newer models do not have switch battery power to the diagnostic connector. And finally, give the customer a copy of the customer instructions found on the back cover of the CoPilot instruction manual. Photocopy the instructions onto an 8.5 by 11 sheet, leaving room for customer notes. The MDS CoPilot is a convenient, efficient, and accurate tool for diagnosing troublesome intermittent conditions. Thanks to the CoPilot, you can now devote your valuable time to servicing vehicle problems and not just looking for them.